I think. You know the Pythagorean Theorem, right? Yeah? Okay, good. That's what we're doing today. So, mostly review. All right, here we go. So we're talking about the Pythagorean Theorem. We're going to use this whole unit. And you're just going to have to know, hey, I got to use the Pythagorean Theorem today. Okay, there we go. So we want to be able to solve problems using the Pythagorean Theorem. And we can use the Pythagorean Theorem when we have a right triangle. Very, very, very important. You must know that it's a right triangle. Otherwise, it's not very helpful, okay? So we can use the Pythagorean Theorem to find the missing side of a right triangle. Find the missing side of a right triangle. In this particular picture, A and B are called the legs. Very good. All right, side C is called the hypotenuse. Very good. Very important. A hypotenuse only exists in a right triangle. Okay. How do we recognize the hypotenuse? Yeah, so wherever the right angle is, it's opposite that right angle. So it's the side opposite the right angle. And that's really, really important. And this is the most important thing. So you always want to make sure that you identify the hypotenuse. For any right triangle, then, we can use the Pythagorean Theorem, which says a squared plus b squared equals c squared. But I prefer leg squared plus leg squared equals hypotenuse squared, okay? So I much prefer to say, hey, square your legs, add them up, and that equals the hypotenuse squared. So really important that we want to make sure that we're always equaling the hypotenuse, all right? So that's the important part there. So we want to find the value of x and round each answer to the nearest tenth. I'm going to go ahead and we're just going to start with number 3. So we want to round to the nearest tenth, very important. So we have calculators handy. So where's our hypotenuse? 9 is the hypotenuse. Right here is 9. So what can we do to set this up? Equals the 9 squared, the hypotenuse squared. Does it matter if you did x squared plus 7 squared? Not at all. Okay, great. So we have 49 plus, hello.
I need more time on my exam.
Okay. Go ahead and finish that up. Should be good. Make sure everyone has the new code. Okay. Yeah. All right. What'd you get?
32, and then you put the
square root, yeah. So you subtracted the 49 and got 32, and then you did a square root.
And you got 5.6, but then you rounded up to 5.7.
Okay, cool. So what I want to do, because we just did radicals, right? Radical 32, let's say I want to get an exact answer, because this is a good one. 32 is what times what?
8 and 4.
It's true, 8 and 4. Also, divide it by 2 for me. 16 times 2. These both have perfect squares, it's true. Which one's the better? 16 times 2, because that is the biggest perfect square. And so if I wanted to simplify this, I'd look at 16 times 2 and say, hey, what's the square root of 16? and then that radical 2 stays underneath. So 4 radical 2 is the exact answer, but if you put it in your calculator, and this is a great way to double check as well. So the square root of 32 is 5.65, and if we round it to the nearest tenth, Katie, what did you say we get? 5.7, beautiful. Approximately 5.7, but also want to see if 4 radical 2 gives me the same approximation. So 4 radical 2 also gives me the same approximation. So it's a good double check to make sure, hey, did I simplify that radical correctly? So if radical 32 and 4 radical 2 give you the same answer, then at least you know you simplified that radical good, okay? All right. Let's look at number 5. So we want to find the value of x. What is this x representing here? A leg. Okay. Yeah. Does anyone remember what this dotted line is called? Well, it is technically, but it's not clear why. But it comes down and it's perpendicular to the opposite side. Does anyone remember what that name of that thing is? Altitude. Altitude. An altitude comes from a vertex and goes perpendicular to its opposite side. So that dashed line there has a special name. It's called an altitude, and we're trying to figure out the length of the altitude. That's what the x represents. The other markings here, we know that this triangle, this is a special kind of triangle. What's the name of that triangle? Isosceles. Very good. Isosceles. It has 2 congruent sides, which means it also has 2 congruent angles, all right, because if congruent sides, then congruent base angles, okay. And because of that, we have congruent angles here, and another pair of congruent angles, and a congruent side. We have angle sides. So these 2 triangles happen to be congruent, which is why, Quentin, when you said it's a bisector, it's an angle bisector, it is, because our triangles are congruent. Okay, we have 2 congruent triangles by angle side congruency. Just to go back, way back, okay, it's important to think about. Now, if these 2 triangles are congruent, this altitude did something magical. What happened to the side that was 22? It gets split. Yeah. And each of these is 11. And that's only true because it was an isosceles triangle. That is not true all the time. Okay? So because we knew it was an isosceles triangle, we get congruent triangles. So it's really important to understand how we know those are 11, because it's not always the case. All right? Now that I know that, what's the setup to figure out x here? Where's our hypotenuse? 24 is the hypotenuse. All right. And we have a little triangle.
24 to the power of 2 minus 11.
True. Yeah, we would get there. So I'm going to do leg squared plus leg squared. I'm always going to set it up exactly how I'm supposed to, only because I'm a teacher. And yes, you can skip a step. So leg squared plus leg squared equals that hypotenuse squared. You're going to go ahead and square both of those. So let's do 121 plus x squared equals 576. Then we need to do what? Subtract the 121. So 14255. Okay, 455, and then we're going to square root both sides on your calculator. Let me know if you need any. How do you do that? You know. So we get 21 point. Yeah. 21.3-ish. 455, if I were to try to break that down, 455, I know it's divisible by 5. And 91, nope, not divisible by 17. Is 91 prime? I can't remember. I think it is prime. So 455 is 5 times 91, and I am pretty sure that 91 is prime. And so there's no perfect squares in there. It doesn't simplify. Square root of 455 is the exact answer. All right. So it doesn't simplify beyond that. All right. Number 6. Again, we're trying to figure out the height here of this sort of trapezoidal figure. Any thoughts on how to do that? Well, where's the hypotenuse? 2 hypotenusi? Is there a right triangle? Period. Do we see a right triangle somewhere? No. Not really. Yeah, it's a 4-figured thing. Can we make a right triangle somewhere? Yeah, you think? Where should we do that?
Where that, like, corner.
Okay, where the lower corner here is? And then, so you're saying maybe if I know that this is 5, maybe I can drop a altitude again, so it's parallel to this other side, so I've got like a rectangle here. So what happens on the top here? What's the length of this little bit? Really?
That's 5.
It's also 5 because I just made a rectangle, right? So this is 5. This would also be 5. All right, what happens to this other side of my triangle here? 13. Good. All right. So yeah. So these kinds of problems are really about making shapes and making sense of shapes. Okay. So this hopefully will work. I'm going to go ahead and just reset it because. Okay. P654Z. Okay. There you go. Thank you. All right. So this is 13. Okay. So now if this side was X, what's this side? Also X. Yeah. So we just created a little rectangle. That's a great thing. And now we see that right triangle that we love. So how do I set up my right triangle there?
13 squared equals X squared.
Where's the hypotenuse? 16 is the hypotenuse, right? Okay, so leg squared. Okay. 13? 13? Okay, so x squared plus 13. So leg squared plus leg squared equals hypotenuse. Yeah? 16 squared. Okay. We're there, right? Everybody's there? Yeah, you're good. Do I need to solve from here? No? Okay. So x is approximately 9.3 when you get down to it. So really we're going to focus on the setups here. All right. Fantastic. Now, number 7 here. Again, we're trying to find the length of this whole entire side. How many right triangles do you see? 2. Yeah, there are definitely 2 right triangles. A left side and a right side right triangle. And so in order to figure out x, on this particular problem, I can't just use the big triangle. I can't just say, hey, 14 squared plus 29 squared equals x squared. I cannot do that. How come? It does, yeah, that big one, we don't know if this is a right angle. It doesn't tell us, so we cannot assume. All right? So instead, I have a little triangle here on the left, and I have a bigger right triangle here on the right. And what I'm going to do is I'm just going to say, hey, we're going to call this side length A, and we're going to call this one B. Can I figure out A? Can I figure out B? Can I add them together? Okay, so let's see. To find A, what's my setup?
12 squared
equals 14 squared. A squared plus 12 squared equals 14 squared. Great. And what's my setup to figure out B?
12 squared, B squared,
Plus B squared
and 29 squared.
equals 29 squared. Great. All right, so we have two little equations that we can solve for, and let's see. Will you take a moment and go ahead and just do that for me? Go on. Okay. All right, so I get A is about 7.2 and B is 26.4. So how do I figure out X? Add them up. So 7.2 plus the 26.4, and I get 33.6. So finding those triangles is a good thing to do. Questions so far? Good. All right. Let's look at number 8. All right, for number 8, I have to find the length here of this leg of a right triangle, so it is part of a right triangle. But do I have enough information to figure out X with this triangle? No. What do I need to do you suppose?
Figure out the bottom one first.
Yeah, figure out the bottom one first. Yeah. I want to figure out the length of this side, so I'm just going to call that Y and call it whatever letter I want. And now I can figure out Y first and then use that to figure out my X triangle, okay? So let's see, leg squared plus leg squared equals my hypotenuse of 25 squared. So let's see, I'm going to do 25 squared, subtract the 10 squared, and I get Y squared equals 525, and then take a square root. So I get Y equals 22.9. All right, so I know that Y now is 22.9. And what can I do then to figure out X?
So you put in 22.9
Okay.
to the power of 2 plus x to the power of 2 equals 28 to the power of 2.
Beautiful. So 22.9 squared plus the X squared now equals our 28 hypotenuse squared. All right, cool. So then I can do 28 squared. I'm going to subtract the 22.9 squared. Goes to 59.59. And then I can square root my answer. Okay. Do you know the answer button is in blue at the bottom? Right there. It calls up the previous answer. So you can do second answer, and it just pulls in sucks in your previous answer, which is a great, quick thing. Okay, cool. Do you have questions for me? Okay, cool. So we do have some applications. What I'm going to do is we're just going to set these up because that's the hardest part. And I'm going to say on applications, draw a picture. You have to make sense of the problem. So it's really, really important that your first step when you have a word problem is to draw a picture, okay? So a roofer leaned a 16-foot ladder against a house. Okay, I have a house. There it is, little chimney with smoke, front door, windows. Look at that cutie right there. All right, there's my house. And I got a 16-foot ladder that he's leaning against the house. So here he is. There's my 16-foot ladder. That is the length of the ladder right there, leaning against the house. Okay? If the base of the ladder is 5 feet from the house, where do I put the 5?
Underneath.
Yeah. Here's the base of the house, so the 5 must be like the grass that it's sitting on. So right there is the 5 feet, and of course, it's not the Leaning Tower of Pisa, despite my picture. We have a little right triangle right here, because hopefully my house is standing straight up, okay? We assume that it is, all right? And so, if this is my triangle, how high up the house does the ladder reach? Well, that's assuming we want to know to the top of the ladder, so that would be X right there, the height. Okay. What's my setup?
X to the power of 2 plus 5 to the power of 2 equals 16 to the power of 2.
Beautiful. And we can solve from there. Okay. So draw a picture. Make it interesting. Really take the time to understand what's going on, and you'll be much better for it. Number 11. Kurt is building a rectangular deck. A rectangular deck. What should I draw? A rectangle. Oh, God, you guys are brilliant. All right. All right, there's our rectangular deck. Rectangles have right angles. That rhymes. Rectangles have right angles. If the dimensions of the deck are 10 feet by 23 feet, what does that tell me? What are dimensions? The length and the width, those are the dimensions, yes. So we have 10 feet by 23 feet, all right? Those are dimensions, the length and the width. What is the length of the diagonal? Great, do I have a diagonal in this picture?
No.
Can I draw one?
Yeah.
Absolutely, it's diagonal. It goes from corner to corner, and it wants to know what is the length of the diagonal. So that's the X there, what we're trying to figure out. What's our setup? Good. 23 squared plus 10 squared equals the X squared, and you can solve for X from there. Fantastic. All right, number 12. Ashley jogged 3.4 miles to the east. All right, so here's Ashley right there. She started, and she jogged 3.4 miles east. So 3.4 miles, and she went eastward. All right, and then 5.7 miles south. So south would be straight down. So there we go, 5.7 miles south. How far is Ashley from her starting point? So now she's here at the end of her 5.7 mile trek. How far she is from her starting point is the straight line distance from where she began to where she ended. So once again, we have a lovely, how do I know it's a right triangle?
Because of that corner.
The corner, because we went heading east to south, and that would definitely be a 90-degree angle then, okay? And of course, I think you can set that up, no problem. And then 13, 31-foot support wire is attached from the top of a 25-foot telephone pole. Okay, I have a 25-foot telephone pole. So, okay, here's my telephone pole right there. It's 25 feet tall. And a 31-foot support wire is attached from the top to a point on the ground. All right, so I have a point on the top to a point on the ground, and that wire is 31 feet. And it's pretty common to see those wires. How far from the base? How far from the base of the pole does the wire meet the ground? So again, if we're at the base of the pole, we want to know how far away that wire is. So this is what we're looking for. And again, what assumptions can we make here? It's a right angle because the telephone pole should be straight up into the ground, perpendicular to the ground. So that's pretty easy. I think that one, important. The wire comes from the top of the pole to the ground. So again, make sense of your pictures. Do you have any questions for me right now? All right, we have one more quick thing to talk about. So turn page. Okay, So this is a slightly new thing here. The Pythagorean theorem can actually be used to determine if we have an acute or an obtuse triangle. And so given a triangle with sides A, B, and C, let me draw a picture. So first of all, we know that if I have a right triangle with sides A and B and C, it would look like this, right? And if it's the right triangle, then A squared plus B squared equals C squared. So I'm going to write that down. So we know right off the bat, if C is the hypotenuse, right? And it also happens to be the longest side, okay? So if the longest side of your triangle squared is equal to the sum of the two shorter sides, then the triangle is a right triangle, okay? So right off the bat, if the longest side is equal to the sum of the squares of the two shorter sides, we know it's a right triangle. But maybe the square of that longer side is much, much bigger, all right, than the square of the shorter sides. So if that longest side squared is much bigger, so if C squared is greater than the sum of the squares of the two shorter sides, then what kind of triangle do we get here? Obtuse, exactly. It is an obtuse triangle because it's that longest side is too long, and so our triangle flattens out, right? We get the obtuse angle, all right? The other hand, maybe that C squared, that longest side squared, is less than the sum of the A and the B squared. So if C squared is less than the A squared plus B squared, what did you say?
Isosceles?
Not isosceles. Acute, yeah, this becomes an acute angle, something less than 90 degrees. So then the triangle is acute, all right? And so it's sort of important to be able to kind of visualize what that might look like. And that's why I like to draw the little pictures here. So here we have that obtuse angle, and here we have that acute. All three angles happen to be acute, but so it's good to sort of think about that sort of visually. And so always keep C squared on the left side to avoid confusion when classifying, just so it matches what we've set up here. And remember, C is the longest side. So we want to look here. Let's see. First determine if the three sides, first determine if the three sides could form a triangle. Interesting. What happened? How do we know if three sides form a triangle or not? Katie?
You add the smallest sides together.
Okay.
Bigger than the largest.
The third, yeah, very good. So in order to form a triangle, the two littler sides, so in this case 3 and 7, have to be greater than the third side. Always really important. So very good. Is 3 plus 7 greater than 9?
Yes.
Okay, so yes, we have a triangle that works. So that's really, really important. Otherwise, those two sides fall flat, right? We would get a sort of, it wouldn't have a roof, in other words, okay? So then what we want to do is determine, then classify the triangle as acute, right, or obtuse. So I'm going to take my longest side, so that's 9 squared, and I want to know how it relates to the sum of the other two sides. And so we have 81, question mark, plus, 9 plus 49? 3 squared is 9 and 49. Okay, so let's see, 81, and then that becomes 58. 81 is greater than 58. So that longest side is bigger than the sum of the other two. So what kind of triangle is it? It's an obtuse triangle. Very good. So that's this picture. That third side squared is longer. So flattens out that triangle. Cool. All right. Let's see. Let's look at number 3. So first, is it a triangle?
No.
Yeah, 4 plus 11 is not greater than 16. 15 is not greater than 16, so this is not actually a triangle. All right, and let's go down to number 7. So number 7, again, I want to check to see, is it a triangle? So let's see, 31 plus 35, is it greater than 39? Yes, it is. So yes, we have a triangle. And then I want to compare my side lengths, my squares of my sides. So 39 squared, how does it compare to 31 squared plus 35 squared? All right, let's see. What's 39 squared?
Um, 1,501.
Beautiful. And then I'm just going to use my calculator the quick way. 31 squared plus 35 squared, and I get 2186. All right, so let's see, 1521 is definitely smaller than 2186, so that definitely gives us that acute triangle, or that longer side is short compared to the sum of the other two. So get a acute triangle. Okay, do you have questions for me? All right, cool. Well, that was only 31 minutes.